Okay, guys, Assalamu alaikum. Very good afternoon, all students here. Welcome back. Today we have a new topic related to object-oriented in this programming technique 2, which is polymorphism. So basically, this course is the main core of this course is related to composition, aggregation, polymorphism, inheritance, exception. So all these concepts are the core of this course. So before I start this lecture, I'd like to highlight some issues about your class diagram that you have submitted right now. So referring back to e-learning here, in fact, I already checked what you have submitted here. I think it's not clear right now for you, the idea, what I'm looking for in your design, your project. Basically, this project is not about web design. It's not shopping, online shopping. This is not the core idea. The core idea is how to map the concepts of composition, inheritance, polymorphism, how you implement these concepts in this real life example. So now to make it easy for you, uh, graphical user interface is not required from you. You just implement with the simple code. You have just coding with CMD, just the shell. You ask the user to key in the biometrics for the first login. If he is already registered, you can retrieve from the file the information. So you move from class to class. I'll make it simple, the implementation, but what I'm looking for is the class diagram, because if the class diagram is wrong, you will implement something is wrong, something is missing. For me, I cannot see all these concepts there. Some of you try to make inheritance, but still missing composition, but can we implement all these concepts together in this project? This is the key idea. If your class diagram is correct, the implementation will be just straightforward. You just make simple shell, you ask to login, and so on. So I will give you another extension for 1 week, and you have to start from here. If you see the assignment of aggregation, so you start from here in your class diagram. So basically, your class diagram must consist the following classes. So let me explain what I'm looking for. I'll use the pen here. Okay, guys, you understand me, because this is very important. If your class diagram is wrong, the rest will be wrong. Okay, guys, you start from here to make it easy for you, because some of you still confused with biometric. Biometric is just one class. It is the login. And instead of using username password, you just key in the biometric. If you are using face recognition, meaning that assuming that we have a camera, the camera already read the features of the face, what's the length of the face, what's the color, maybe 3 attributes are enough. So you have to start from here first. So your class diagram must consist of shopping cart, because it's online shopping. So I have to see this class. So this is a class, right? Then I have a customer for this shopping cart. I must see this class. Then I have items. So what kind of items? Now from here you will see this is item generic class. It's the father. So I will make inheritance from this class. I have a book, right? So this is generic. Any item in the shopping cart, in the online shopping, must has a name and price. But what kind of item? So now I can use the inheritance. So this item is a book. So the book. What's the difference now? What features you can add here? Maybe we have a color for this book. Maybe we have the weight of this book and so on, the number of pages, right? Then from this book, I can make more inheritance. So the book consists of what? Consists of chapters, right? You see, I want to see this concept. I have chapters. Maybe if you don't like to use these chapters, maybe you have two kind of book. Is it hard copy or soft copy? So I have inheritance here. I have two classes. Sorry. So I have one class. This is hard copy. And this is another class. This is soft copy. You see, I can implement this concept. So you add features, add attributes and functions. You can make it the hard copy if you want to extend more, whatever. It's based on your design. So it's up to you. Soft copy, is it CD or MP3? Right? We have another class here. So I can see multi-level inheritance. So this is one check. You have inheritance in your design. For this class, what kind of payment you can do? Is it cash? So is it cash payment here? Is it credit card here? Is it credit card? So this is inheritance also. Credit card. Is it check? You see? Credit card. Is it MasterCard or what? Or Visa card? So this is MasterCard. This is Visa card. It's simple, not complicated. Some of you give me some complicated that you cannot implement later. I want to see simple concepts there. So I have aggregation here. So if you come here, this is customer. Customer is what? You can make inheritance up. This is person. So I have two different type of customers. Is it regular customer or customer is member with membership? So this is customer. I can make down. This is with membership, but this customer is just guest. Is it clear for you what I'm looking for? You have to start from here. Any question? Is it clear my explanation here, what I'm looking for in your class diagram? Don't make it
Yes.
complicated. Yeah, clear? Yeah, you have to start from here. Then you have to think where I can implement the composition. Then for the polymorphism, you can try to implement here how the MasterCard is working, because polymorphism about the functions. All can you do payment, but the payment here is different. So I can see polymorphism here. Okay, clear? Polymorphism means that you will change the function. The payment here is different from the payment here. Both of them have, but here is different. So if I can see all these concepts, it will be correct. For this customer also, you can extend if you would like. The customer has address here. So there is address in your register. For the login then, the most confused part, you just make login class. So this customer must link with aggregation with what is, we must have aggregation or composition here. It's aggregation because you have just when you log in, you create a link. So this is the login class. Inside this login class, use biometric. Biometric is just features in the login. You just 3 or 2 attributes, whatever. Biometric is not the key idea. You just make login class, then you choose which class of biometric you wish to use. And instead of password and username, we just replace. Okay, clear the biometric. Biometric is just replacement of username and password. Okay, Claire, I will give you 1 week. You start from here like this. If this is clear, then you can implement without graphical user interface. And to see also if you can do the sequence diagram, how it works. Also, plus the class diagram in order to make sure that it's clear for you before you go to the implementation. I'd like to see the sequence diagram. So of course we don't cover a sequence diagram, but you can do it here. I will try to explain for you. The sequence diagram here, I'll try to explain. So for the sequence diagram, assume that we have a user here. This is our user, the first login. So the user, this is sequence diagram, we call it sequence diagram. So the first time the user will log in, it will check with what, with, for instance, with the main program. So in the main, you'll ask, are you new user or existing user? So if it's new user, you have to register. Then you have to register. If not, so it's some kind of sequence. After login, you have to choose. You want to view the website. Are you viewing, browsing, or you select item? Then you have the selection. So it's a sequence of how it works, your website. If we have a new user, what's the steps? So please add these steps in all scenarios. Just cancel the payment if you choose to. So it is some kind of asking, you are asking, but all like blocks you can refer in the Google, you check what's the sequence diagram. This will help you to implement. It will be very easy for you to do the coding part. If the sequence diagram is correct, you know how it works. The class diagram is correct, all the classes there, then the implementation will be straightforward. Okay, so I'm expecting from you to submit, to update your class diagram first. Based on what I explained, the class diagram you have to update and submit again. Then you have to add the sequence diagram. Because if I can see if something is wrong before you go to the implementation. If something is wrong in sequence diagram or class diagram, I can update you before you go to the implementation. Okay, guys, clear for you? I'll give you 1 week up to the end of next week to update your class diagram to try to give me the sequence diagram. If you don't know what sequence diagram, you can refer to Google. It's just the steps. Steps as a sequence. You ask, you reply, you ask, you reply, you see what's the behavior. Maybe you have scenario 1, we have user used MasterCard. You have scenario 2, we have user used cash. You have scenario 3, there is a user come but no shopping. So you have to view all scenarios. After that, you go to the implementation. Okay, guys, any question before I refer back to my slides here? Do you have any question about this? Is clear for you how to update from here? I hope it's clear for you. So today we will start with a new topic, which is polymorphism. So basically, what's polymorphism? So polymorphism is the ability of objects to perform the same action but in different implementations. So you see, we have insect is the parent, we have the ant and grasshopper, but the movement here is different. All right, so we have the shape diagram here. In the shape diagram here, we have the circle and the rectangle. So in the rectangle, the calculation of the area here you just multiply the width by the height, but for the circle here, you just multiply by with the radius of the circle. So different behavior. Both classes have the same function, calculate the area, but they will calculate differently. All right, so the same action but different behaviors. This is the key idea of polymorphism. You can implement in your project different payment, but within cash is different from credit card. So it's the same action because the classes use the same name, including parameters or methods. It's different behavior because the code inside the function or method is different. Okay, so we have this example here. For the circle here, the calculation of the area is different from the rectangle. All right, so it's different behaviors. We call it different behaviors. So this is the key idea. So now how to implement the polymorphism in coding. So what you have to add in the coding. So before we go to the implementation, we have to recap three terms. So the first one is overloading. So what do we mean by overloading? Overloading meaning that you have, if you have two or more methods, like the constructor, you have default constructor and constructor with parameters. So both functions have the same name, but parameters are different. This is overloading. Different in what? Different in the type or the number. We have two kind of differences. So this is overloading, already covered. We have another concept last lecture we covered when we have a copy from this function. So we call it redefining. So you have the exact copy, the same number of parameters and the same type. So child or derived classes define methods with exactly the same name. All right, and parameters. So it's duplicate, it's copy. So we call it redefining. We have another concept today we will cover. It is overriding. Overridden method. It is the same, but now in the case of redefining, we have a static binding. Static binding meaning that at the compile time, you will link the function with the code. But with overridden, we have dynamic binding. We will link at runtime. Okay, so it's the same, but we have to change the linking here to be dynamic instead of static. So we'll see the examples here. So now in this example, you see we have a class person. So this is the class person is here. We have another class, which is the student. So basically the student is a derived class from a person, right? So what we have inside the person class, we have string name. So in the derived class, we have the metric number. Then in the public class, in the public section here, we have the constructor. We have a function here, set. We have another function here, set. So you see the same prototype here, the first prototype or initial prototype, but the number of parameters here, this is with parameter and this is without parameter. So we call this what? We call this overloading. So this is overloading. Overloading. Overloading as a function or a constructor. Also function you can overload. because you have different type. Then we have a function here, print. All right, so it's print with a constant here. This is the prototype. We are looking for the prototype. This function exists where in the parent class, and here in the derived class, I have the same prototype. I'm talking about the prototype here. So this one and this one, what we call it here, this is redefining. This is the second concept here. It's redefined. Redefined. Okay. So we have the third type here of overridden. So you see here in the prototype, I'll take this one first. So we have a function, who am I? Then I have a function here, who am I? You see right now the prototype is similar, plus we have the keyword virtual. So when you have this kind of cases, we call it overridden. So this is overridden. Okay, so the same, but we have a virtual keyword in front. So you see in the implementation now here, in the case of redefining, because we have static binding, so when you print out, when you call this function, you'll see this is the person name here, and you print out here, you see the student information here. So now, why we are using the virtual keyword? Why we need it here? So let me explain the problems first, then you will see what's the benefits of overriding. All right, so now you see overloaded methods. We have redefined methods, and we have what? We have overridden methods, as I explained. So now the virtual method are a method. Later we'll see what's the benefit. Now we just need to understand the terms. So we are using the virtual keyword in front of the function to make it overridden. So we just add in the parent class. You see here, I'm not adding here virtual. You just add where in the parent class. All right, so virtual methods are methods that are dynamically bound. The binding is decided at runtime, meaning that the linking will be decided at runtime. So at runtime, C+ will decide to which version of the method should be bound by looking at the type of object making the call. So virtual methods are defined with a keyword. We have to use keyword virtual in order to make it virtual function. You just add the keyword virtual. So methods defined without virtual, we call them non-virtual methods, and they will use static binding. The linking will be at compile time. So the binding decided at compile time. All right, so the method name is, so what do we mean by the binding here? So when you compile the code, in fact, in the binding here, if you look at the code here, when you compile this code now, so I'll explain the idea of binding. When you compile this code, so this function now, set, for instance, this one, so automatically this code, when you call this function, automatically you are calling this code. But now when you add a virtual keyword in front, meaning that this function now and the implementation inside is empty. You will decide which one at runtime. Are you executing this one or this one? So if you look at compile time, the link is not there. At runtime, you will create the link. But this one static, so the link is there, meaning that if you call this function, you automatically execute this code. But later, you have to link. If you call this function without linking, you will not see the output. You have to link first. You have to decide which function. All right, so this is the binding. Binding is linking. So the name of the function will be linked with the code. So the method needs to be bound to the code. So this is the key idea. You link the function name with the code inside in order to perform its actions. So method binding can occur in two scenarios. Pre-bound at compile time before the run, or at runtime. We call it dynamic binding. All right, so we have examples here to make it clear. So static binding here. In the case of static binding is about at compile time, the code, as I mentioned for you, the code of this method will be decided or linked at compile time. So methods that are statically bound are constant or unchanged through the execution. Those the static binding. So you cannot change the code inside at runtime. So all methods except overridden methods are statically. So basically, all methods will be static unless you add the virtual keyword in front. All right, so we have redefined, we have overloaded constructors, destructors. So all these functions will be statically binding unless you add the keyword virtual. All right, so this is the static. In the case of the dynamic, so it will occur at runtime. We will decide which code that you will be executed. What you have to do, you have to add the virtual keyword in front. This is done by adding the virtual in front of the parent class. You see here, I'm adding only in the parent class. No need to add in the derived class. So you see this example here, we have a class. So this is class is shape here. So from this class, I have a circle and the rectangle. So the rectangle here, in the implementation here, we have get area here. So now, if you look at the prototype here, we have the first prototype in the parent class. So it is integer get area in the derived class. So it's the same prototype. In the rectangle class here is the same. So because you are using the same prototype, so we call it redefining. So you are redefining the code. So now what's the problem if you execute this code? Now in the main program here, what we have a pointer of type shape. So we have three objects. So this is shape object S. We have a circle object C. We have the rectangle object R. All right, so now I'm using the pointer shape to take the address of the shape first. So I'm linking here. Then I'm calling the function get area. So basically now executing this line, you are calling this function here. So what's the output will be? The output will be 0 here. In the second one here, I'm changing this pointer because it's pointer of type shape. You can link it with a class circle. It's the child. You can use the pointer because it's generic pointer. So now I'm changing the pointer, I'm changing the length. So now I'm interested in the second class, so to calculate the area. So if you print this line here, you are still pointing here. All right, so because this is shape, so it will call this one. So you will get 0 also. Then we are changing the pointer here to the rectangle. So we print out, but unluckily you're still pointing here. You will get 0. Why? Because this is shape pointer. So shape is linked with this one. All right, it's linked here to this function. So you will see here the expected output, so zeros. So this is the expected output because of the link. Clear this idea, this static binding. When you offer, you redefine the function without using the virtual keyword. So you will get this output. So this is the problem of static binding. Clear this idea before move on to the solution of this problem. Is it clear for you what's expected to happen here? Any question before I move to the second slide?
No.
I have a question. Why do we have written 0 there inside the bracket?
The implementation here of this function, this shape. Shape initially gives 0. You don't know what kind of shape. It's shape. This is, you cannot give formula. Is it circle or what? So you implement, if you make it empty here, so nothing will be displayed here. You'll get null.
I say, all right, thank you.
You see, yeah, welcome. So we make it generic, then we define. All right, so any question before I move to the solution? Is it clear this problem? Why we are linking to the parent function? Because this pointer is binding to here at compile time. So you link to this function. So what's the solution now to break this link? You have to add virtual. So basically the solution is very easy. You just add virtual keyword here. So there is no link at compile time. When you compile, this pointer will not be linked here. So the solution comes in the second slide, you see. So output error of the area of circle and rectangle. So what's the solution? So the method get area stated with pointer b, it's pre-bound to compile time, so it's static binding, so it's remain unchanged at runtime. So thus, every time calling the method get area, the pointer shape always linked to get area of the shape class because of b of type shape pointer. As a result, the output will be always 0. So this problem can be solved using dynamic binding. How? You just add what you see here. We are adding a virtual in front of the prototype. So this is the key. No need to add here. If you add it here, this is wrong. If you add virtual, add only one time at the parent class. All right, so specify the solution, specify virtual to use dynamic binding. So meaning that there is no link at compile time. The compiler will not link this function with this pointer. There is no link between. At runtime, you will specify the link. So now virtual is used only place in the parent class. So this is very important. You just use it in the parent class. So now what's the expected output now with the dynamic binding here? So uh, you see the expected output. Now you see different. This is the right calculation. Okay, clear for you. What's the problem? How we solve it? So because we have the polymorphism, we need to redefine the functions. You have to reuse them. So this problem will happen with you. So you have to use virtual keyword. Is it clear for you? This is the key idea of dynamic binding. Any question before I move on in the slides here? All right, I assume it's clear for you. So static, so the solution here with dynamic binding, so the method get area is now bound at runtime, not pre-decided anymore at the compile time. So at runtime, C determine the type of the object making the call and bends the method to the appropriate version of the function. So at line 42, pointer B, if you refer back to 42, this is 42 here. Now you are changing the length. So you are linking here. All right, so at line pointing to circle object, that's the method get area set with B, now is bound to get area of class. We change again at line 45. So 45 here. We link with this function. All right, but you have to use the keyword virtual. Otherwise, this will be binded here. It will be fixed. But with virtual, there is no link at compile time. This is the key idea. All right, so the method must be able to be dynamically bound. This is done by making virtual method place the keyword virtual in the parent class. So you just put it in the parent class only. There is no virtual here. Okay, clear this idea. I assume it's clear for you. So you have to place it only for the method to make polymorphic. This will allow the method to be dynamically bound. So basically, the polymorphic here is you using different representation. This is the idea of polymorphism. You change the behavior. This is 0, but here we have the formula. Sorry, it should be here. We have the formula of calculation. When you change the formula here, this is the polymorphic here. But when you use virtual, this is the dynamic binding. It's different concept. We allow the pointer to change the behavior. Otherwise, here, what's another solution here? You can call this function directly without using pointers. If you use here without virtual in the previous one, where is the main? Sorry, this one. Okay, without using virtual, how you can solve this problem now? So what you have to do, you have to use this directly without pointer here. What you can use, you change this one with we have B here. This is S. You just say S object as object dot get area. So you are linking to this one. Here you have to use the object C dot get area. So you are linking to this one. And here also you can use the object. So r dot get area. So through object there is no problem. But to make it more practical, to make it at runtime, the pointer will decide you have to use the virtual. Otherwise, if you are using the object through object, you can call these functions without any problem. You can get the right output here. Okay, clear this idea. Now we are calling through pointer. So with pointer, you have to use virtual. So must use parent class as we have mentioned here. We did here. So the conditions here for the implementation. So the method must be able to dynamically bound. This is done by making virtual. You make it in the first step. If you want to use dynamic binding, first you have to add the virtual keyword in the parent class. Then the second step, the child class need to override. So you have to override like here. Need to override the polymorphic method. So it's polymorphic method because we are changing the behavior. Then step three here, you must use a pointer. If you use object, there is no problem with object. So you have to use pointer of type what? Of type shape. So you cannot use here a pointer of type circle. So it's pointer of type circle to link with this one. So the pointer must be of type parent class. Okay, clear this point, the pointer must be defined as a parent class type.
Excuse me, doctor.
Yes,
So if I use a parent of a child class, like for example, if I created a new pointer
of
of
circle.
an object circle, yeah, it won't work.
Yeah, you cannot say this pointer C2 equal the address of R. They are different. Rectangle
No, no,
is
I mean if
different.
I used like no, no, I mean if I used like if a pointer of type circle that have an address of an circle object,
In
not
that
another
case,
object.
yeah, of circle. If type circle, this pointer of type circle can be linked only to this class. Or if you have derived class,
Yeah,
you have
okay.
another derived class. But now it doesn't make sense to use a pointer. Use object directly. If you want to use this one, just you say c dot get area. No need to see c2 pointer get area. It works, but it doesn't make sense. Use the object directly. Why you are
Okay.
taking the address, yeah. But in case of shape, you have to make it generic, then you can change at runtime. At runtime, you are changing here. You see this implementation here. So you see in this implementation here, we have different implementation right now. We link with a function. So this function here. So in this function, I always send a different address, but this one must be generic, must be parent. If this one is circle here, this will be wrong, or rectangle. Must be generic, so you can link with different addresses. Okay, guys, clear at this point. You have to be aware about the pointer type and the virtual keyword. All right, so parameter B can accept any
Okay,
address
thank you,
of
doctor.
object shape, welcome, shape, circle, rectangle, because it is type shape pointer. You can accept from the derived class pointer of derived class with the parent class, but you cannot accept from different classes. Should be the same type. Okay, guys, so we have three steps just to recap to make it dynamic binding. First, you have to use the virtual keyword in the parent class. Then you have to do the polymorphism. You have to change the behavior. And third point here, you have to use a pointer of parent class. So three steps must be implemented in order to make it dynamic binding. So now you will get the same output here. We have different implementation. We are calling through function. So just we move to a function, this call. Okay, guys, so if you want to use last, you have another implementation also. If you want to implement in the main, we have 3 objects here. Then we have a list of pointers. Because if type shape, so you can give shape, circle, R, 3 different pointers. But all of them are derived or the same type. So you can use list of pointers. So you can print out, you can call this function through pointers, list of pointers. So this is another implementation here, third one. So you'll get the same output. You can implement using function, you can implement direct call, you can implement as a list of pointers. All right, clear this idea? We just changed the implementation, but still the key idea is there. All right, so you see here the array must be of type parent class in order to assign the derived class here. All right, so each element of the array is a pointer of shape. Circle, rectangle can fit because they are also of type shape. It's fit. Type circle fit with the shape. Also type rectangle can fit with type shape. Okay, use a row because it's pointer. We use a row. Just implementation here. So parent class pointers. So the pointers must be declared of the parent class pointer. So that any object of the child class and the parent class can fit. In other words, make it more general. So this pointer must be of type shape. Okay, guys, we can pass address of any object of circle, rectangle, so the same idea here, because R and C are all of type shape. Okay, we are passing here to the function. I think this is the end of today. We have parent class pointers. We will just check this example here. In the main, we have this is shape will be linked to circle, then you call the idea. Here is the important point. Through the pointer P of type shape, if you refer back to the implementation of this code here. All right, so you can see here now in the shape class. So this is shape. We don't have any attributes here. But through this pointer, I can access a function, public function of get area. So I can link with dynamic binding through a shape pointer. I can access this function. But you cannot access this private value here. This is the radius. You cannot access a member function here. You access only the public functions. So you see this key idea here. You cannot access, we have example here. This one. You see now, I have a function print radius. You can access now through this pointer. You can call this function, but you cannot access the radius r. So you see the output here. A pointer b is pointing to circle object, then you can access. This is fine because the class shape has, the idea here, you cannot call this function. Even it's public, you cannot call it because it's undefined here. you can call this function because it's already known for the class. But from the main idea, you cannot access from the parent to the child because inheritance is upward. From the derived class, you can access public functions in the parent class, but the opposite is not true. But here in our case, because we already have this function, we just change the link. So this function is a copy from this function. So you can call it here. It's fine. But here is wrong because this function is belong to the derived class. So you see the note here is error. Error why? Because class shape doesn't have the method parent. Is it clear this idea? This pointer can access only the functions that are already defined in the parent class. You just change the address. But other functions you cannot access. Okay, clear this point? So again here, you can access getArea function because it's implemented here. But you cannot access this function because it's not implemented in the parent class. Okay, guys, clear this idea here? So by default, the constructor, next lecture, we will start with the destructor, how we can make the destructor virtual. So this is the end, right? This slide, I hope it's clear for you. Just to recap, you have to use the virtual keyword to make it dynamic binding. With the pointer, you cannot access all functions. You just access the functions that's already implemented in the parent class. Any question before I end today's lecture? All right, I assume it's clear for you. So next class, we will continue with the remaining part of the slides. So I will update the deadline for the submission of the class diagram plus sequence diagram. You make it together in one single file. You just show me the steps of the sequence that will follow when a user login into your website. All right, guys, I hope my point's clear for you. So I need to stop my sharing here. Just a minute to share with you the attendance. So I need to stop my